Question number 1, we're asked to expand the brackets and simplify. So part A, first of all, we have 3x minus y in brackets, and that's to be squared. So what that means is we're going to multiply the bracket by itself. So we have 3x minus y multiplied by 3x minus y. What that means is we have everything in the first bracket and we multiply that by everything in the second bracket. We do that one thing at a time. So if we first of all take 3x from the first bracket and we multiply that by the second bracket, so 3x times 3x minus y. Then we take the second thing from the first bracket, which is negative y, and then we multiply that by the second bracket also. So multiplying through on the brackets, so we have 3x multiplied by 3x first of all. So 3 times 3 is 9, and x times x is x squared. Then we have a negative, and then we have 3x times the y, which gives us 3xy. Then we have our negative y multiplying the second bracket. So first of all that multiplies 3x. So we get negative and then 3xy. Just arranging the letters in the same order as the previous term. And then we have the negative y times the other negative y. So a negative times a negative is a positive, so it's plus. And then y times y is y squared. So what we have now is 9x squared minus 3xy minus 3xy plus y squared. Collecting the like terms, which is this one and this one, we get 9x squared minus 3xy, take away 3xy is minus 6xy. Then we have our plus y squared, and that's the end of that one. Moving on to part B. So again, we want to expand and simplify. This time we have two brackets. It's x minus 4, the first bracket, multiplied by this slightly longer bracket, x squared plus 5x minus 2. So the same procedure applies as before. We want to multiply everything in bracket 1 by everything in bracket 2. So we do that one step at a turn. Okay, so the first term in the first bracket is x, so it's that x multiplied by the second bracket, which is x squared plus 5x minus 2. And then it's the second thing from the first bracket, which is negative 4. And then we multiply that by the second bracket also, which is x squared plus 5x minus 2. So multiplying this out, first of all we have x times x squared, which is x cubed, plus, and then x times 5x, which is 5x squared, then x times 2, or negative 2, which is negative 2x. Moving on to the second one, we have negative 4 multiplying the second bracket, so negative 4 times x squared is negative 4x squared. Negative 4 times plus 5x is minus 20x, and then negative 4 times negative 2, a negative times a negative is a positive, and 4 times 2 is 8. What we want to do now is collect the like terms. So we have a plus 5x squared and a negative 4x squared, which we can put together, and minus 2x and minus 20x. So putting down our x cubed first of all, plus 5x squared and minus 4x squared gives you plus 1x squared or plus x squared. Then we have negative 2x and negative 20x, which gives us negative 22x. And finally we have our plus 8. That's us simplified it as far as we can, so that's our final answer. Question number 2. We're told a line has an equation y equals 3x minus 2. Part A of the question asks us to copy and complete the table below for this line. So the table has a row with a few x terms given, 3, 0 and negative 2. And we want to find the corresponding y values. And we get those by using the equation at the top. So the equation at the top tells us that we multiply the x values by 3, and then we subtract 2, which will give us our y value. So the first x value is 3, so multiplying that by 3, 3 3s are 9, then subtract 2 gives us 7, so our first value is 7. Our second x value is 0, so multiplying that by 3, 3 times 0 is 0, and 0 take away 2 is negative 2. Then our last x term, negative 2, multiply that by 3, 3 times negative 2 is negative 6, then subtract the negative 2 on the end gives us negative 8. So that completes our table. Part B asks us to write down the gradient of the line. So in order to find the gradient of the line, what we do is use the gradient formula, which is m equals y2 take away y1 over x2 take away x1. In order to use this equation, we need 2 points, and what we have up here in our table is just that. That x and y term represents 1 point, here's another, and here's another. We just need 2 of the points, so I'm just going to select the first 2, this one and this one. Now I'm going to write them down first of all. So the first one is x is 3 and y is 7, so we'll call that x1 and y1. And the second point, x is 0 and y is negative 2, so that'll be our x2 and y2. Substituting these values into our gradient formula, we have m equals y2, which is negative 2, and we're subtracting y1, which is 7, divided by x2, which is 0, take away x1, which is 3. So that gives us m equals negative 2, take away 7, which is negative 9, divided by 0, take away 3, which is negative 3. So we now have a negative divided by a negative, which means the answer will be positive, and 9 divided by 3 is 3. So the gradient of the line is equal to 3, and that's our answer. Question number 3. We're told the diagram opposite shows the design for an earring. The design consists of a kite, A, B, C, D, and a circle, centre C. We're told that AB, which is this line here, and AD are tangents. We're then asked to calculate the size of angle BAD, so BAD, which is this angle in here. Now, the important information we're given here is that these two lines are tangents. So from our knowledge of the circle, we should know that the tangent is perpendicular to the radius at the point of contact. So this line here, for example, represents the radius CD, which means that our tangent meets the radius here at a right angle. So we know that that angle is 90 degrees. Similarly, at the other side, because we have a tangent and a radius, we have another 90 degree angle. Now, if I split the kite exactly down the middle, then what we get is we get two triangles. So we can think about this one, for example. So what we have now is a right angled triangle. There's a right angle. And we also know one of the angles because it's going to be exactly half of 136, which means it's 68 degrees. That's the size of that angle in there. What we want to do is we want to find the size of BAD. So if we work out this one here, that will be half of BAD. And we can quite easily work out the angle that I've marked in blue, because as we mentioned, this is a right angled triangle now, and the three angles in any triangle must add to 180 degrees. So if I add 68 and 90 together and then subtract from 180, we should be able to find the blue angle. So 68 add on to 90. So you can do this in your head, that's fine. It's 158, but if not, we can use the sum here. 8 add 0 is 8, and 9 add 6 is 15. It gives us 158. We then want to subtract that from 180, to find the size of the blue angle. So 180, take away 158. Again, if you can do it in your head, that's fine. 0 take away 8, you can't do. So go to the 8, cross it out, make it 7, and carry 1 back. That gives us 10 take away 8, which is 2, 7 take away 5, which is 2, and 1 take away 1, which is nothing, which leaves us with 22 degrees, which is the size of this blue angle in here. So angle BAD, the one that we are actually asked to work out, is going to be double that. 2 times 22 is 44. So quickly showing you how to work that out in the sum. 2 times 2 is 4. 2 times 2 is 4. So angle BAD is 44 degrees. Question number 4. We're asked to find the equation of the line shown opposite. Now our line here has been drawn for us on, and we can quite clearly see the x and y axis, and it's plotted on with a grid shown in the background. So the easiest way to do this question is to work out the gradient and the y-intercept and substitute into the general equation of a straight line, which is y equals mx plus c, where m stands for the gradient of the line and c is the y-intercept. Now the y-intercept, first of all, is very easy to see. It's where the line crosses over the y-axis, and that's quite clearly shown here as -3. So we can write that down first of all. We already know that c, the y-intercept, is -3. Now in order to work out the gradient, there are a few ways to work out gradient, but the simplest way to do it in this case is to draw a little triangle, picking out 2 points, drawing a little triangle, and using the formula m equals v over h, vertical over horizontal. So we'll zoom in slightly, we'll pick out 2 points that we can use. So there's a particularly good point we could use, and here's another one. If we draw a little right angled triangle now, we can quite clearly see that the vertical height of that triangle is 1, 2, 3, 4 boxes. So the vertical height is 4. And the horizontal distance of this triangle is 2. The line quite clearly slopes in a positive direction. So zooming back out again, we can substitute into our formula, which is m equals vertical over horizontal. The vertical height is 4, the horizontal distance is 2, and 4 divided by 2 is 2. The gradient is positive, and we can tell just by looking at the way the line slopes. So now we have the gradient 2, we have the y-intercept -3, so we can substitute that into the general equation of the line. So that means we have y equals -2x minus 3, which is the equation of the straight line. Question number 5, it's a two-part question. Part A asks us to factorise 2x squared plus 8x, and then part B says hence simplify, and then we have 2x squared plus 8x over 2x squared minus 32. So obviously the thing to spot here is that this and this is quite clearly the same. The word hence means we're going to use whatever we do in part A and part B. So we look at part A first of all, just move to one side. So we have 2x squared plus 8x, and we're asked to factorise. Now you should remember that factorise means that we're going to put the brackets back in, and we're looking in this particular one to take out a common factor, the highest common factor. So the highest number that goes into 2 and 8 is 2, and also we can see that x goes into both terms as well. So the common factor, the highest common factor, is 2x. So 2x times x gives us our 2x squared above, and 2x times 4 gives us our 4x. So that's our answer to the first part. Moving on to the second part of the question. The question in part B says, hence simplify 2x squared plus 8x over 2x squared minus 32. Presence of the word hence here tells us that we're going to use this answer in part 2. So the numerator, the top of the fraction, 2x squared plus 8x, we are now going to substitute in our answer from the first part on the numerator in the place of 2x squared plus 8x. So that would then give us 2x bracket x plus 4 on the top line, and on the bottom line we have the 2x squared minus 32. So what we're looking to do is simplify here. We factorised in the top line, and that's what we're now going to do in the bottom line, and then hopefully we'll get something that might cancel or simplify somehow. So the numerator, 2x bracket x plus 4, and on the bottom line, factorising this one, we're going to take a common factor out first of all again. We have an x term in the first part but no x term in the second part, so our common factor will just be the number 2. So 2 outside the bracket, leaving us with x squared minus 16 inside. Now what we need to be able to spot here is that we have another type of factorising available to us, and it's x squared minus 16, which can be converted into a difference of 2 squares. At the moment it's not quite there because we don't have 2 squares, we have x squared, but then we just have 16 here. But we can write 16 as 4 squared. So our next line of working, top line will stay the same, and the bottom line, I'm going to prepare it for a difference of 2 squares, so I'm going to write it as x squared minus 4 squared. So now that we have it like that, we can now factorise by a difference of 2 squares on the denominator, the bottom line. So our top line remains unchanged for the minute, and the bottom line, well, we have our 2 as our common factor out at front, and then to factorise by a difference of 2 squares, we factorise into 2 brackets, one with a plus sign, one with a minus sign, and then it's just x and 4 and x and 4. So what we have now is we have a fully factorised top line and a fully factorised bottom line. We have an x plus 4 bracket on the top, which can then be cancelled with the x plus 4 bracket on the bottom. And then we have the 2 on the top, which can cancel with the 2 in the bottom. That leaves us with x on the top on its own, and on the bottom line our x minus 4 in the bracket. We don't really need the bracket, so we can get rid of it at this point. That's our answer fully simplified, and the end of the question. Question number 6. We're told a painting valued at £16,000 in 2008 is expected to increase in value at a rate of 5.5% per annum, which means per year. And it's going to do that for each of the next 4 years. The question asks us to calculate the expected value of the painting in 4 years' time. Then, quite importantly, it asks us to give us our answer to 3 significant figures. So we'll need to remember to ensure to do that at the end. So if we think about the original value of the painting, it would be represented by 100%. If we're talking about an increase in value of 5.5%, then that takes us up to 105.5%. Now, to write 105.5% as a decimal, it would be written as 1.055. So that's going to be our multiplier for our calculation. We have £16,000, which is the starting value, and we're going to multiply by 1.055, and that's to the power of 4 because it's for 4 years. We then take our calculator and we work that out. So the answer from the calculator is 19821.5 0.194 and so on. Obviously we're talking about money here, so we don't need all those digits. In fact, in this question, if we remember, we are to round to 3 significant figures, so that will be the 1, the 9 and the 8. The digit after the 8's a 2, so that means we will round to 198, and then we need our 2 zeros, which gives us £19,800, the new value of the painting after 4 years. Question number 7. A fisherman makes a cork float from 2 identical cones of diameter 4 centimetres with a common base. Calculate the volume of this float. So first of all, we need to know how to work out the volume of a cone in order to do this question. So the volume of a cone V is equal to 1/3 pi r squared h, where r is the radius of the cone, the base of the cone, and h is the height of the cone. Now, our diagram is 2 identical cones joined together. We're just going to work out the volume of one of the cones and then multiply it by 2. We'll assume that you have a calculator for this question. So, first of all, we need to identify the radius and the height. So, 4 centimetres here, we're told is the diameter, which means the radius will be half of that. The radius will be equal to 2 centimetres. And the height from the top to the bottom of the float is 6.1 centimetres. The height of one of the cones will just be half that, which is 3.05. So we'll just note those down at the side. Substitute those values into our formula. We get V equals 1/3 times pi multiplied by the radius squared, so that's 2 squared, multiplied by the height, 3.05. If we key that into a calculator now, we get 12.77 and so on. That's the volume of one cone. We won't clear our calculator screen yet because we need to multiply by 2. So if we now multiply by 2, we get the volume of the float, V, which is 25.551 and so on. We open round to 1 decimal place, so that's 25.6, and that's cubic centimetres. So that's our answer, rounded to 1 decimal place. Question number 8. The diagram opposite shows the sector of a circle with radius 18 centimetres. We're asked to calculate the area of the sector. The first thing to notice is that the angle they give us, 65 degrees, is not the one we want to use. We want the angle in here, which will be 360 take away 65, which is 295. Then we need to remember the formula for area of a sector. So we'll just AOS, area of sector, equals pi r squared multiplied by the angle, which is 295 over 360. The radius is 18 centimetres, so that's pi times 18 squared multiplied by 295 over 360. If we key that into our calculator, we get an answer of 834 point and then several decimal places. We'll round to 1 decimal place, so our answer is 834.1. So it's area, so it's square centimetres, and our answer was rounded to 1 decimal place. Question number 9. A storage bin has a cross section in the shape of a rectangle and a semicircle. So this is the cross section here. We're asked to calculate the volume of the storage bin. So the first thing to notice is that the storage bin is a prism, which means if we want to work out the volume, it's the area of the end multiplied by the length. So the area at the end is the area of this cross section multiplied by the length from the front to the back, which is 80 centimetres. So the shape at the end is a composite shape. We're actually told this it's a semicircle and a rectangle. So if we split that into two shapes, we can quite clearly see that we have our semicircle area at the top, and we have our rectangle area down here. So to work out the total area, we'll work out the red semicircle area and the blue rectangle area, and then we will simply add them together. So looking at the blue rectangle area first of all, that's probably the simplest one. So we'll just call that the blue rectangle to keep our working nice and neat. So it's a rectangle shape. The area of a rectangle, as you should know, is the length times the breadth. Substituting in the length and the breadth, the length is 62, the breadth is 30. So that's 62 multiplied by 30. If we use a calculator, then we get the area of the rectangle, which is 1,860 square centimetres. We'll just separate our working down the middle here. Now working on the semicircle. So we have the area of a circle first of all, which is pi r squared. And since there's a semicircle, we'll just divide our answer by 2 at the end. So the area of a semicircle is pi r squared, as you should know. So what we need to do is identify the radius. So if this were the centre point of our circle here, then the radius would be the centre point to the outside of the circle, which is clearly halfway along the full width of our storage bin. So the radius would be 31 centimetres. So that's area equals pi multiplied by 31 squared. Using our calculator here, we get an answer of 3019 with several decimal places. We'll round to 2 decimal places at this point because we're not quite finished yet. So that's 0.07. And again, that's square centimetres. So what we want to do next is we want to find the total area of the cross section. So, and our total area is the red and blue sections added together. That gives us 4,879.07. That's the area of the cross section. The volume of the prism formula, V equals the area of the cross section multiplied by the length, is what we move to next. To remind ourselves of the length, it was 80 centimetres from the front to the back. So that's what we substitute in. We have V equals, and then it's 4879.07 multiplied by the length, which was 80. Again, go into a calculator. We get the answer for our volume, which we will round to 1 decimal place this time. So it's 390,325.6. That's cubic centimetres, since we're now talking about volume. And that's the end of the question.